Hello students, today we're going to discuss JEE Main 2025 questions from chapter Units and Dimension, January attempt, that is attempt number 1. So we divided this chapter into two parts. Today we're going to see the second part. Suppose if you didn't see the first part link is in the description, so don't forget to watch that. And we have a page in Instagram and WhatsApp group. Do join the group to explore more regarding physics. And also don't forget to subscribe our channel to watch more video like this. So let us start with the questions. See the first question. The least count of a screw gauge is 0.01 millimeter. If the pitch is increased by 75% and number of division on circular scale is reduced by 50%, the new least count will be. So first we'll take the formula of least count. Least count is equal to 1 PSR by n. N is number of division in a circular scale, that is equal to 0.01 millimeter. Okay. So in the question they have given the condition pitch is increased by 75%. So initial PSR plus it's increased by 75%. So plus 75%. So 75 by 100 PSR. So this will be 0.75. So that will be 1.75 PSR. And for total number of division on circular scale, it's reduced by 50%. So number of division is n. It's reduced to 50%, means minus 50 by 100 n. So this will become 0.5. So the answer will be 0.5 n. Okay. So now we can substitute in the formula. So the new least count LC dash is equal to, in the place of 1 PSR, we can substitute 1.75 PSR. And in the place of n, we can substitute 0.5 n, that is equal to 1.75 by 0.5 into 1 PSR by n. So it's an initial least count. We know the value, it's 0.01. We can substitute the value. Before that, we can cancel this. This will be 1 and this will be 3.5. So we can substitute as 3.5 into 0.01. So this will be 35 into 0.001. So this will be 35 into 10 power minus 3 millimeter. So the answer will be 35 into 10 power minus 3 millimeter. Next question for an experimental expression. So why they have given the equation where all the digits are significant. Then to report the value of y, we should write. So first, to handle this question, we have to write the significant figure for all the values. So 32.3, it has 3 significant figure. 1125, it has 4 significant figure. Again 27.4, again it has 3 significant figure. So in the question, the least significant figure is 3. So in the answer also, the least significant figure has to be 3 only. So you can check the option 4. Only in option 4 you have 3 significant figure. So option 4 is the right answer. Next question, in a measurement, it is asked to find the modulus of elasticity per unit torque applied on the system. The measured quantities as the dimension m power a, l power b and t power c. If b is equal to 3, they are asking the value of c. So first we'll expand the condition. So the modulus of elasticity means Young's modulus per unit torque. So for Young's modulus, we have a formula stress by strain. For stress, we have a formula force by area. And for strain, change in length by original length into torque tau. Okay. So for strain, we don't have a dimension formula because both are linked, so it will get cancelled. So balance force by area into torque. So now we'll substitute the dimension formula. For force, mlt power minus 2. And for area, it's L square. For torque, it's a dimension of energy. So ml square t power minus 2. Okay. So now we can cancel the terms. So L and L will get cancelled. T power minus 2 will get cancelled. Mass will get cancelled. So balance m power 0, L power minus 3 and t power 0. Okay. So here they have given the value for B and value for the C. In the place of C we have 0. So we can write value of C is 0. Next question, a tiny metallic rectangular sheet has a length and breadth of 5 mm and 2.5 mm. Using a specially designed screw gauge which has pitch of 0.75 mm and 15 division in a circular scale, you are asked to find the area of a sheet. And also they asked maximum fractional error. So to handle this question, first we'll find the least count of the screw gauge. So least count is equal to 1 PSR by n. N is total number of lines in a circular. That is equal to 0.75 millimeter and n is 15. So if you calculate means, you will get it as 0.05 millimeter. This is the least count of screw gauge. Okay. So to find the maximum fractional error, we have to take the formula for the area of sheet. Area is equal to length into breadth. Now we'll take the propagation of error. In the place of A, we can substitute del A by A. That is equal to, in the place of L, del L by L. And in the place of B, del B by B. Okay. So now we can substitute the value. So they didn't give the error for length. So because of that, we can take the least count as its error. So we can substitute 0.05 millimeter. By length, they have given it as 5 millimeter. Same way for breadth also we can take the same least count. So 0.05 and breadth is 2.5. If you want, we can write it as 5 by 2. So 5 will be in the denominator and 2 will go to the numerator. So del A by A is equal to 0.05 plus 0.1 by 5. So which will be 0.15 by 5. So if you cancel means this will be 1 and this will be 0.03. So you can write it as 0.03, but you can check the question. It's in the form of x by 100. So I'm going to multiple and divide by 100. So that is equal to 3 by 100. So in the place of x, you have 3. So answer is x is equal to 3. Next question, we have to find the dimension formula for the following quantities. That is angular momentum, force, energy and pressure. Force and energy are basic quantity. For that, we have to know it directly. So for the force, ml t power minus 2, that is B matches with first one. And for energy, ml square t power minus 2. So C matches with 4. And then we have to find the dimension for the angular momentum. So for that, we can take the formula. Angular momentum is equal to mvr. For mass, it's capital M. For velocity, L t power minus 1. For radius, which comes under length. Okay. So for L, we can write it as M L square t power minus 1. So you can see the A matches with second one. And last one, pressure. For pressure, the formula is force by area. So already we know the dimension for force, that is M L t power minus 2. And for the area, it's L square. So L will get cancelled. So for pressure, it's M L power minus 1 T power minus 2. So you can see option D, that is D matches with 3. So from this we can check the option. Option 3 is the right answer. Next one, which of the two physical quantity has the same dimension? So first we have to find the dimension formula for all this quantity. So first we'll start with angular momentum. For angular momentum, in previous problem we have seen the dimension formula. So we'll repeat it again. So for angular momentum, mvr. So for mass, m, and for velocity, L t power minus 1, and for length, L. So that will be m L square t power minus 1. So again we have to find the dimension for Planck's constant. So for Planck's constant, we can use de Broglie wavelength, that is lambda is equal to h by mv, that is momentum. So we can reform this equation. So h is equal to lambda mv, where wavelength is a length, so comes under L. So for mass m and for velocity L t power minus 1. So that is equal to m L square t power minus 1. So you can see here the Planck's constant and angular momentum has the same dimension formula. So option 1 is the right answer. Next question, the velocity of a particle moving on a straight line varies as time. They have given the equation where A, B, C are constant. So we need the dimension of A, B, C. So first, velocity is the first term, AT square is the second term, and BT by C plus 3 is the third term. Okay, so in this also, C plus T, the dimension of C and T will be same. So C is equal to the dimension of T. Okay, so first data. And first term, velocity. So velocity has a dimension L t power minus 1. Okay. So second term also have the same dimension of velocity. So we can substitute. So second term, A t square is t square, that is equal to L t power minus 1. So A is equal to L t power minus 3. Okay. So the dimension of A is L T power minus 3. So coming to third term, so it's B. In the place of T, we can substitute T. In denominator, C and T both has a dimension T only. So we can substitute T, that is equal to the first term dimension, that is again L T power minus 1. So T will get cancelled. So B is equal to L T power minus 1. So we have found the dimension of A, B and C. Now we'll substitute in the question, that is the dimension of A, B, C is equal to, in the place of A we have L T power minus 3. In the place of B you have L T power minus 1 and C is T power 1. Okay, so T will get cancelled, balance L square T power minus 3. Okay, so we check the option L square T power minus 3. Option 3 is the right answer. Next question, we have to find the unit for the following quantity. So magnetic induction, magnetic intensity, magnetic flux and magnetic moment. So first we'll start with basic one, magnetic flux. For magnetic flux, we know the unit is Weber. So C will match with 2. And magnetic induction means the SI unit is Tesla. We have one more unit, that is Gauss. That is 1 Gauss is equal to 10 power minus 4 Tesla. So magnetic induction will match with 3. And magnetic moment we have a formula NIA. For N is number of turns, we don't want to take that. For current we can take ampere. For area we can take meter square. So ampere meter square. So magnetic moment will match with 2. Balance magnetic intensity, that will match with 4. Okay. So A matches with 3 and B matches with 4. C matches with 2 and D matches with 1. Option 2 is the right answer. So next question. So we have to find the dimension formula for the following quantity. So first we'll start with Young's modulus. For Young's modulus formula, stress by strain. For stress, force by area. For strain, change in length by original length. For strain, we don't have a dimension formula because both are length, so it will cancel. For force, dimension formula ml t power minus 2. And for length, it's L square. So it will become L power minus 1 t power minus 2. So the Young's modulus A matches with 2. And second one for torque. So for torque we have a formula R cross F, that is RF sine theta. So sine theta is a trigonometry function, so we don't want to take. So for R it's L and for force it's M L T power minus 2. So again the dimension formula M L square T power minus 2. Okay. So the torque matches with 4. And next, coefficient of viscosity. For coefficient of viscosity, we can take the formula F is equal to 6 pi eta RV, where 6 pi is a constant, so we can neglect. So coefficient of viscosity eta is equal to force by radius into velocity. So for force, again ml t power minus 2. For radius L, for velocity L t power minus 1. So L will get cancelled. So m L power minus 1 T power minus 1. So this is coefficient of viscosity. So it will match with 1. And last, gravitation constant. So for gravitation constant, we can take universal law of gravitation. F is equal to G m1 m2 by r square. So for G is equal to F r square by mass m1 m2. So for force, we can substitute m L T power minus 2. For radius L square. For mass m and m, mm will get cancelled. So balance m power minus 1, L power 3, T power minus 2. Okay. So at last, gravitation constant will match with 3. So Young's modulus matches with 2 and torque matches with 4. C matches with 1 and D matches with 3. So option 4 is the right answer. Last question, a physical quantity Q is related to 4 observer values A, B, C, D. So they have given the equation. Also they have given the value for A, B, C, D. So we have to find the percentage error in Q. First we'll take the equation, that is Q is equal to A, B power 4 by C into D. Now we'll write propagation of error. In the place of Q, we can substitute del Q by Q, that is equal to del A by A plus 4 into del B by B plus del C by C plus del D into D. Okay. So we need in the form of percentage. So we're going to multiply by 100 on both the sides. So into 100 and into 100. Now we'll substitute the value. So A is 60 and del A is 3. So we'll substitute the value. So A is 60, del A is 3. So 3 by 60 plus 4 into, again del B is 0.1 and B is 20, plus in the place of C it's 0.2 by 40, and in the place of D we can substitute 0.1 by 50 into 100. Okay, so if you calculate this means you will get the answer as 0.077, but they asked in the form of x by 1000. So I'm going to multiple and divide by 1000. Okay, so this will become 77 by 1000, that is equal to x by 1000. So in the place of x we got 77. So 77 is the right answer. Okay students, we have completed all the questions from units and dimension chapter which they asked in January shift. So we came to end of the session. If you have any doubts or queries, do comment in the comment box. And to watch more videos like this, don't forget to subscribe our channel. Thank you students.